Reno. I don't know what to say. It's more of this top K. What is it called? Top K, top K, top K, top K. I think it's just top K coding strategy, whatever you want to call it. You know. So yeah, let's get into it. It's called Task Scheduler. Given a characters array task representing the tasks a CPU needs to do, where each letter represents a different task. Tasks should be done in any order. Each task is done in 1 unit of time. For each unit of time, the CPU could complete either one task or just be idle. However, there is a non-negative number n that represents the cooldown period between two same tasks, the same letter in the array. That is, there must that is that there must be at least n units of time between any two same tasks. Return the least number of units of time that the CPU will take to finish all of the given tasks. Um, yeah. I guess if we go through this solution or like the sample example, right? We have three A's, three B's, and an N of two. So that means there has to be 2 units of time between the two same tasks, right? Like this is essentially what I was talking about yesterday when it was like I think it was like the rearranging one. It's like with n or like k distance, but like it the k distance isn't like how do I say it? The number in between is like it includes like the last one. So in that one where like k equals 2 would be like a would be valid, right? But like so this one's like the more natural way of thinking it, at least for me. So you want 2 units of time in between the two uh, tasks of the same type. And then so you would want AB, and then since you have no more tasks to do, you idle AB, idle AB. You realistically speaking, you could BA, idle, BA, idle, BA, idle as well, right? Um, I don't think. I mean, also you could also probably do something like A idle B, A idle B, A idle B. Oh, actually, no, that'd be a bit longer. That'd be longer. So like you could do BA idle, BA idle, BA idle. Oh no, BA idle, BA idle, BA, or AB idle, AB idle, AB. Right. So yeah, kind of complex, whatever. Um, well, at least the way I was thinking about it. But yeah, so let's get into it. So basically, whenever you see a top K problem, you probably want to use heap queue. So we're just gonna import all or like import star, whatever you want to call it, just so I don't have to type heap queue in front of everything. Um, there's not really an edge case here because there's a non-negative integer n. Therefore, I guess okay. Actually, it could be 0 in a sense. I don't know if it actually tests for it, but what we're going to do is if n is equal to 0, we just return the length of tasks. Because if it's 0, you don't need any space in between, right? So you could just A, B, 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 and so it would just be whatever the amount of tasks there is. And non-negative should include 0 if I am not trolling. Um, but yeah, sounds about right. And now, so we'll get into implementing the actual solution, right? So we need to create a max heap, but in order to do that, we need to first create essentially like counter, right, or like a dictionary or whatever or map that stores all of the counts. So we create a dictionary called dict. Since it is like a reserved word in a sense, you can still use it, but it's a reserved word. You might not want to use it, but I guess for the sake of time and my sanity, so I don't have to type like longer answers in a sense, I'm just gonna use dict. Maybe use something else, but yeah. Dict task is equal to dict.get task 0 plus 1. This essentially just sets we just count how many times each task shows up in tasks, right? And so if we get task, it'll give us the value that's already in the dictionary. If there is no value, then we just get 0 plus 1 because we're incrementing the count, right? Pretty simple. Here we're going to create our max heap, which is implemented as an array because of heap queue. So for key value in dict.items, we're going to do heap push max heap. We're going to do negative of the value because we want a max heap, and heap queue is implemented as a min heap. So doing this will give us a max heap. And now we're going to have result is equal to 0. Result is basically just a result, right? It's going to be how many units of time that the CPU will need to take to finish all of the given tasks. But yeah, you could call it time, whatever. I'm just going to call it result. And so while max heap, this just means while max heap has stuff in it, we're going to be doing stuff, right? So we're going to do a cooldown, or like, I could use tasks, but I'm not going to use tasks. Let's just use, I'm just going to use cooldown actually. It's n plus 1. Maybe cooldown isn't the, we'll do to do, right? So basically, since you want 2 in between, you're able to fit 3 tasks before you're able to do the same thing, right? So that's why it's to do n plus 1. So in an ideal world, like not ideal world, sorry. Like here, we would do what do you call it? You would do 3 tasks before you can do A again, right? So with that logic, we need to do n plus 1 tasks. Okay, that's what I was trying to say. We need to do n plus 1 tasks, and then so that's why we need to do n plus 1, and then we're gonna do done. Done. I'm just gonna do done. It's not the best word you can use here, because we're just going to use done to represent essentially the number of tasks it takes for, like, the number of tasks that we have done in this iteration, like within the count of to do, right? So while to do is greater than 0 and the length of max heap is also greater than 0, that means we can do more tasks and we have more tasks to do, right? So here we're going to do the frequency, and the task is equal to heap pop off of max heap, right? And then so we're going to do done dot append task and frequency plus 1. The reason why we're doing frequency plus 1 is because up here the frequency we're setting as a negative value, so plus 1 will take us closer to 0. If we were to minus 1, it means we have to do the task more times, and essentially we'll never finish this like code loop, right? So we'll just do plus 1 here, and then so result is plus equals 1 because we just did a task, and then to do we'll do minus equals 1 because in this loop we are doing like one less task. Like we need to do one less task to complete like our cooldown cycle, right? So that the first task that we do will be off cooldown, and so we can just push it on, just so we can push that back onto the stack or like the max heap, just so we can do the tasks that have the most iterations that need to be done first, just so we can have the shortest amount of time possible, right? And so after you do this, ideally you would run out of to do, but it's also possible that you run out of just tasks to do. So you'll come down here and you'll do for frequency, for task and frequency in done, you'll do heap push max heap. You have to do another check. If the negative of frequency is greater than 0, then you want to push it back onto the heap, right? Otherwise, there's no need to push it onto the heap, because if we push it onto the heap, then we will be misrepresenting what tasks we need to do. So we'll heap push only if we have to do more than one frequency left, because if we negate that, then it's greater than 0. Or you could also do this and just do less than 0. But logically speaking, this makes more sense, where If the frequency is greater than 0, then we need to do more. And the reason why we have to negate it is because we have to negate it for the max heap. So we'll do this, or you could also even go further. You negate this and then -1 instead, and then here you just do frequency greater than 0. Yeah, so here we'll just do frequency on the task, right? And then if the length of max heap is greater than 0, this just means we have more tasks that we need to do. If we have more tasks that we need to do, then if we have more tasks that we need to potentially tackle in the future, we need to make sure we handle all of the cooldown. So we'll do result plus equals to do here, or this embodies the cooldown, right? So we'll do plus equals to do. Ideally, in one of in this early on, since n equals 2, right, we need to do 3 tasks. So we get A, B, C, and then so we push the A back on. So A is what, 5 now? Yeah, A5, D1, E1, F1, G1, right? And so we know that we have more tasks to do, and so we need to fulfill our cooldown in case we didn't, right? But since we fulfilled the cooldown here, we'll just be adding 0 onto result, so that actually doesn't change anything. It only starts changing stuff once we finish D and E. Once we finish F and G, after we finish F and G, we still add 0 onto the thing. But once we tackle this A, we will exit because the length of max heap is not greater than 0. So we'll come here, we'll push stuff back onto the heap, but then we realize, hey, we still have more tasks that we need to tackle, so we need to add on the cooldown. And so that's why we'll add on the 2 cooldown here, and then we'll go back through the loop again, right? And then at the very end of this, we'll just return result because we've handled all of our tasks, because what the while max heap condition here, actually I'll just do while the length of max heap is greater than 0. Greater than 0, typing is a bit hard. We'll just do that, and then you'll return result at the very end because it just counts the number of tasks that you have tackled, or the number of units of time in order to satisfy this whole thing. We'll submit it, and boom, it works. So yeah, with that being said, thanks for watching.